For centuries, we've looked up at the night sky and our eyes have always been drawn to that little red dot, our neighbor, Mars. But what if the answer to one of our biggest questions isn't hidden in some faraway galaxy, but is actually right next door? Today, we're digging beneath the red dust to uncover the secrets hidden on its surface and buried in its ancient past.
It's pretty much the biggest, most profound question we can possibly ask. It's the one that drives our science, our stories, our imagination. Are we just a one-off, a happy accident in a vast, empty cosmos? Or is the universe absolutely teeming with life?
Well, it turns out the best place to start looking for an answer might not be light years away. It could be right here in our own backyard, on the fourth rock from the sun. The great search for life begins on Mars. So, how do you even begin to look for life on a whole other world? It's not as simple as you might think. It's more like a complex investigation, what I like to call the Great Martian Mystery. Okay, first things first, let's get one thing straight. Forget everything you've seen in the movies. The real scientific search for life on Mars has absolutely nothing to do with little green men or ancient alien civilizations. The reality is actually way more subtle, and honestly, way more fascinating. Scientists are basically cosmic detectives. They're looking for tiny microscopic clues, faint chemical signatures in the air, and ancient hints in the rocks that could point to life. Either life that's there right now, or life that died out a long, long time ago. And just like any good detective story, it is all about the evidence. So if we're not searching for aliens, what in the world are we looking for? Let's dive into the hunt for clues. The entire investigation really boils down to two main lines of evidence. First, you've got this mysterious gas that just appears and disappears in the atmosphere. And second, you have what are essentially the ghosts of ancient water carved right into the planet's surface. This brings us to clue number one, methane. Now, here on Earth, a ton of methane is produced by living things, especially little microbes. But, and this is a big but, it can also be created by plain old geological reactions, no life needed. So when our probes spot it on Mars, and they see it coming and going, it creates this huge, tantalizing question, are we seeing a sign of biology, or is it just rocks doing their thing? And this leads to the most exciting possibility of all. See, the surface of Mars is brutal. It's freezing cold and gets blasted with radiation. But what if, just a few feet underground, tiny microbial communities are not just surviving, but thriving, protected from all that harshness and just sort of burping out little puffs of methane into the thin air? It's a wild idea, and it's a huge driver of our exploration today. All right, let's jump to our second clue. For this one, we have to rewind the clock, like billions of years. The Mars we see today is a frozen desert, but it wasn't always like this. Not even close. The rocks tell a very clear story. Mars used to be a very different place. And how do we know this? Well, our rovers have sent back incredible evidence. We're talking about photos and analysis of ancient river deltas, the floors of vast dried-up lakes, and we've even found minerals in the soil that can only form in the presence of liquid water. It is stone-cold proof that Mars once had the number one ingredient for life as we know it. So we have the clues. Now let's meet the investigators on the ground, the ones doing all the hard work, our robotic detectives. The evolution here has just been incredible to watch. We started with the trailblazers, Spirit and Opportunity, who proved we could do it. Then came Curiosity, which is basically a mobile chemistry lab. Right now we have Perseverance, which is collecting rock samples to one day bring back to Earth. And what's next? Rovers that can think for themselves, true AI explorers. And this is so important to understand. We're not just taking pictures anymore. These modern rovers can drill into rocks, they can zap them with lasers, and they can figure out what they're made of right there on the spot. It gives scientists back on Earth this unbelievable access to an alien world. But there's a huge problem. Depending on where Earth and Mars are in their orbits, it can take up to 20 minutes for a radio signal to travel from here to there, and then another 20 minutes for a signal to come back. You can't just joystick a multi-billion-dollar rover when there's a 40-minute lag. So this is where AI has to step in. Just imagine a future rover rolling along when it spots something, a weird-looking rock that might be a fossil. Instead of waiting 40 minutes for instructions, its own onboard AI can identify the target, analyze its options, make the decision to go investigate, and then do all the science, beaming the results back home after the fact. It becomes a real robotic field scientist. And, their job goes way beyond just pure science. These rovers are our scouts. They're our advance team. They're mapping the land, testing out technologies, like how to make oxygen from the Martian air, and they're finding resources and flagging hazards. They are literally paving the way for the day human boots finally join their wheel tracks in that red dust. All this technology, all this effort, all this money, what's it all for? What's the end game here? Well, it all brings us back to the ultimate question. The stakes in this search are unbelievably high. I mean, think about it. If we find evidence that life started all on its own on Mars, that would almost certainly mean the universe is filled with life. But if we find that Mars, a planet that had all the right ingredients, is completely sterile, well, that would suggest that life is an incredible, precious miracle, and that our home, Earth, is even more special than we ever imagined. So you see, this isn't just a mission for a few scientists in a lab. As this quote gets at, it's really a mission for all of humanity. It touches on the deepest questions we have about our own place in the cosmos. In the end, it really doesn't matter what we find, or don't find. The act of looking, the act of searching, is a victory in itself. This whole journey pushes our technology forward. It inspires a whole new generation, and it's just a perfect testament to that basic human need to see what's over the next hill, or in this case, the next planet. So, as we keep exploring that red world, you start to realize the mission has kind of changed. The search isn't really about finding aliens anymore. It's about finding a deeper understanding of life itself and where we fit into the whole cosmic picture. In a way, the search for life on Mars is really a search for ourselves.